Hello everyone and welcome back to Moo Techie. It's wonderful to have all the dairy technologists and cheese enthusiasts with us for another class. This is class 11 in our cheese technology series, where we continue to explore the diverse world of cheese. Today we're moving into the realm of processed dairy products, focusing on processed cheese, cheese spreads, and processed cheese foods. Let's start by defining what processed cheese is. Processed cheese is made by blending natural cheese of different ages with water, salt, color, and an emulsifier into a homogeneous plastic mass. This blend is then heated and continuously mixed to create the final product. A processed cheese spread is a specific type of dairy product that contains a high moisture content, low acidity, and has a soft spreadable consistency. Processed cheese foods are another category. They are dairy products that contain less moisture, less fat, have a lower pH, and are processed at a higher cooking temperature compared to other types. According to the Food Safety and Standards Regulations of 2011, or FSSR, processed cheese is officially defined as the product obtained by grinding, mixing, melting, and emulsifying one or more varieties of cheeses with the aid of heat and emulsifying agents. The regulations allow it to contain cream, butter oil, and other milk products, with a maximum of 5.0% lactose content in the final product. The regulations also state that processed cheese may contain salt, vinegar, spices, condiments, and seasonings. It can include natural carbohydrate sweetening agents such as sucrose, dextrose, corn syrup solids, honey, maltose, malt syrup, and hydrolyzed lactose, provided they are properly cooked. The total amount of these added sweetening agents shall not exceed 1/6 of the weight of the total solids of the final product on a dry matter basis. Furthermore, processed cheese may contain not more than 4% of permitted emulsifiers or stabilizers. The salt content shall not exceed 3% in the finished product. It may also contain preservatives, specifically up to 0.1% sorbic acid or 0.1% nisin. Crucially, it shall have moisture not more than 47% and milk fat not less than 40% on a dry matter basis. It shall contain cultures of harmless bacteria and enzymes. It may contain other permitted food additives and must have a pleasant taste and flavor, free from any off flavor or rancidity. It must also conform to all microbiological requirements prescribed in the regulations. The definition for processed cheese spread is similar. It is also obtained by grinding, mixing, melting, and emulsifying one or more varieties of cheeses with heat and emulsifying agents. It can contain the same dairy ingredients with a max of 5% lactose. It can also contain the same seasonings and sweetening agents with the same limit of 1/6 of the total solids. The key difference is in its composition. A processed cheese spread shall have moisture not more than 60% and milk fat not less than 40% on a dry matter basis. Processed cheese foods require even higher heating temperatures, typically between 71 and 85 degrees Celsius, which is higher than for standard processed cheese. This high temperature is necessary to destroy spoilage and putrefactive microorganisms, thereby significantly improving the shelf stability of the final product. We can compare these products by their specifications. For processed cheese, the maximum moisture is 47% and the minimum fat in dry matter is 40%. For cheese foods, the maximum moisture is 44% and the minimum fat in dry matter is 23%. For cheese spreads, the maximum moisture is 60% and the minimum fat in dry matter is 20%. A good quality processed cheese has a smooth, compact body and a uniform color. It can be sliced without sticking and it melts uniformly and smoothly. Its flavor can vary from mild to sharp, but it is never bitter, oxidized, rancid, or unclean. There are many advantages to processed cheese. It has reduced refrigeration costs during storage and transport. It has a better keeping quality with fewer changes during prolonged storage. There is a great diversity of types available. It can have a high intensity of flavor. It allows for the ability to reuse cheese scraps from natural cheese production. Its packaging is adjustable for various usages, and it is very suitable for home use. The manufacturing technology for processed cheese involves several key steps. First is the selection and computation of ingredients, then blending and shredding. Next, processing the blend. This is followed by homogenization, then hot packing, and finally cooling and storage. The selection and computation stage involves choosing different types and ages of cheese, emulsifying salts, water, and other optional ingredients. A typical blend composition might be 55% young cheese, 35% medium-aged cheese, and 10% aged cheese to obtain optimum firmness and slicing qualities. The quantity of each ingredient is carefully calculated based on the fat on a dry matter basis, including all ingredients, water, and expected moisture loss. After calculating, all types of cheese are shredded and pre-mixed with other ingredients in a cooker before processing. This step offers advantages, such as achieving a more uniform quality in the end product due to physico-chemical changes occurring at a lower temperature. Processing refers to the heat treatment of the blend by direct or indirect steam with constant agitation. This step has two main functions. First, killing pathogenic and spoilage microorganisms to extend the shelf life, and second, inducing physico-chemical and microstructural changes that transform the blend into a stable product with the desired characteristics. Following pre-mixing, the blend is discharged into the cooker. Ingredients are typically added in this order: ground cheese, a dry blend of emulsifier salt, and other dry optional ingredients, water, and finally flavors. Sometimes, the emulsifying salt is added with a portion of water at the start of cooking, and the remaining water is added later. There are two main processing methods. Batch processing occurs at 70 to 95 degrees Celsius for 4 to 15 minutes. Continuous processing uses a much higher temperature of 140 degrees Celsius for a very short time, 5 to 20 seconds. The specific time-temperature combination used depends on the formulation and the desired characteristics of the finished product. After processing, the hot mass is often homogenized in a two-stage homogenizer at pressures of 15 and 5 megapascals respectively. Homogenization improves the stability of the fat emulsion and enhances the consistency, structure, appearance, and flavor of the processed cheese. The hot processed cheese blend is then transported to packaging machines. It is packed and wrapped in various materials like lacquered foil, tubes, cups, cans, and cardboard cartons. It is often packed in the form of convenient slices. The cheese is then cooled slowly, as this helps develop a firmer body in the final product. The finished product is stored at less than 10 degrees Celsius. It is important that it is not stored under frozen conditions, as this may induce undesirable crystal formation. We can visualize the entire process with a flow diagram. It starts with the selection of natural cheese, considering both type and proportion. Other ingredients are selected: emulsifiers, salt, water, color, flavor, and preservatives. The cheese is shredded. Everything is processed using either batch or continuous methods. The product is then hot packed, cooled, and finally stored below 10 degrees Celsius. Several emulsifiers are commonly used. Sodium citrate is versatile. It firms the cheese with good melting properties, is inexpensive, and has the best general all-around qualities. Disodium phosphate is the least expensive and provides good firming and melting. Trisodium phosphate is highly alkaline and is used in small amounts. It helps produce good slicing when combined with other emulsifiers. Sodium hexametaphosphate produces a tart flavor and a very firm body, but it does not melt easily and is the least soluble. Finally, we can look at cheese powder. Hard cheeses like Parmesan and cheddar can be transformed into a powder. Methods for dehydrating cheese include direct tray drying, roller drying, spray drying, extrusion drying, and freeze drying. To make spray-dried cheese powder, cheese is first ground and stirred with intensive agitation while adding water at 27 to 32 degrees Celsius. The goal is to achieve a dry matter concentration, optimal for spray drying, which is between 35 and 45%. At this stage, melting salts like sodium citrate, disodium phosphates, or polyphosphates are added to prevent fat separation. The well-mixed mass is then pasteurized at 60 degrees Celsius and homogenized. It is spray-dried at about 175 degrees Celsius inlet air temperature and immediately cooled to 29 to 32 degrees Celsius before being packed in bags. Packaging in an inert gas atmosphere and adding antioxidants can further extend the shelf life of the dry cheese. The purpose of making cheese powder is to increase the keeping quality and to reduce the weight and bulk of the cheese. It is used as a functional and natural flavor ingredient in a huge variety of products, including biscuits, savory snacks, soups, bakery items, sauces, dressings, ready meals, and even in processed cheese. Various defects can occur in processed cheese, each with its own causes and remedies. A weak body can be caused by too high moisture content, insufficient emulsifier, too high pH, or an incorrect processing method. The remedy is to reduce added water, increase emulsifier, and employ proper processing. A body that is too hard or firm comes from too low moisture, too much emulsifier, too low pH, or improper blending of natural cheese. This is fixed by adding moisture, reducing emulsifier, and using proper cheese blends. A sticky or gummy texture results from too much young cheese in the blend, too short a processing time, too slow agitation, or poor emulsifier selection. Using more mature cheese, increasing processing time, speeding up agitation, and selecting the right emulsifier can solve this. A hard or brittle texture is due to unsuitable raw material, inappropriate emulsifying salt, or a low pH value. Proper selection of cheese, correct use of emulsifier, and proper processing conditions are the remedies. A grainy and fatty appearance is caused by cheese that is too mature, too little or too much emulsifier, too low pH of the natural cheese, or improper cooling. Proper blending, maintaining correct pH, and ensuring proper processing and cooling are key. Oily appearance or fat separation happens if the raw cheese is too mature, emulsifier levels are incorrect, or water addition is inadequate. Adding more young cheese, using the correct emulsifier level, and adding adequate water can prevent this. Hole or fissure formation is due to gas formation by bacteria like butyric acid bacilli or Clostridium, or by yeast. It can also be caused by trapped carbon dioxide and hydrogen. Careful selection of raw cheese, proper cooking, aseptic packaging, and using preservatives are the solutions. A sandy taste comes from crystals formed by calcium phosphates, using sandy cheese in the blend, or insufficient dissolving of emulsifying salts. Avoid certain phosphates, exclude sandy cheese, and dissolve emulsifying salts properly. A mottled appearance is due to mechanical faults in filling or physicochemical actions. Proper filling and using more phosphate emulsifier can help. Mold growth occurs if the package is inadequately sealed or there is post-processing contamination. Proper sealing and avoiding contamination are crucial. Browning is caused by the Maillard reaction, too slow cooling, too much young cheese, or using blends containing milk or whey solids. Proper blend selection, correct processing, and avoiding milk or whey solids in spreads can prevent browning. Thank you for joining us for this comprehensive class on processed cheese products. Understanding the science, regulations, and technology behind these products is essential for innovation in the modern dairy industry.